Hello everyone. In this session, we'll understand threading in C#. Well, threading is the core concept of operating system, and if you haven't, completed the operating system subject, then I strongly recommend to read threading concept from that subject. Okay, threading is also comes in C, C++, Java, or any other programming language. So what do you mean by threading is basically it is used to perform multiple tasks simultaneously. What do you mean by that? Just like I'm using Notepad over here, I can also use Paint parallelly. I can use Visual Studio parallelly. So that can be done with the help of threading. That's the thing. Now there are two types of threading. One is synchronous, and another one is asynchronous. Another one is asynchronous. Okay, so synchronous means it executes processes, or it executes program one after another. So execute one after other. And asynchronous means it is going to be it can parallel execute the programs. Okay, it executes the program parallelly. So synchronous, it means it is going to be something like that. So it goes sequence wise. So 1, 2, then 3, then 4, then 5, and then 6, something like that. So what does it mean is unless this program 1 is not going to complete his work, program 2 cannot start his work, or program 2 cannot start. Until and unless program 2 is not going to complete his work, program 3 cannot start. So the thing is, the disadvantage here is CPU gets the idle time, or CPU gets a lot idleness, free time. Okay, so this is not good for the efficiency or for any other purpose. Okay, the result is going to be very bad. So lower efficiency, because ultimately other programs have to wait. So what does it mean? It's like until and unless this notepad work is not going to complete, I cannot start the paint, right? That's the problem here. So that's the synchronous threading. The second one is asynchronous. It can be something like this: 1, then 3, then 4, then it can be 2, like then it can be 7, then 6, like randomly it goes, right? So the advantage here, CPU not sit with idleness. CPU is having a lot of work, so CPU not have a lot idleness, so higher efficiency. So in general, you use asynchronous threading and not the synchronous. Okay, until and unless there is no requirement, you don't have to use synchronous threading. You can use asynchronous because it gives you higher efficiency, because CPU is not sitting with idleness. It always have to be work. It always going to be in the work mode, not in the idleness. Okay, so let's understand with the help of program. Okay, so I have this Visual Studio running. Okay, in the main part of the program, what I'm gonna do, I'll take for loop, and I'm going to run this for loop from I equals to 0 to I equals to 10. Okay, and I'll just say that this is main. Okay, I'm so sorry, this is not going to be work. I need a method here, so I'll take a method, public void and test. Let me make my method as static, public static void test1, and then I'll say for integer I equals to integer I is less than equals to, let me say 10, equals to 10. This keyboard is not working. Okay, yeah. So, and I will say C console.writeLine, and I will say test1 is running, and I'm going to make I.toString. Okay, so that's the thing. Okay, so I have a method void test1, and I'm running this test1 method from I equals to 0 to 10, and I'm printing test1 is running. Okay, in a very similar way, I will take another method going to be named as test2. So I have test2, and it's also going to be printed from 0 to 10, and I'll say test2 is running. Okay, now let me take another method, test3. Okay, so I have a test3 here, and test3 is running. Okay, if I want to call this a method, these three methods, test1, test2, test3, in my main method, what exactly I can do? I can simply call with the help of directly the method name. Why I can call these method directly with the method name is because my method are in the static. Okay, so I can directly call it. So test1, then test2, and test3. Now you'll see by default these methods are in the synchronous form. So even if you are not using any threading concept, this is simple method calling, right? A simple method calling is there. So if you see this, it's going to be run like from 0 to 10, and it is in the synchronous form. You'll see that. Okay, let me run this. Okay, you can see here test1 is running from 0 to 10. See here. Okay, and then once this test1 gets completed, test2 start his work from 0 to 10, and then test3 started from 0 to 10. Okay, now as you can see, this is in the synchronous form, test1, then test2, and then test3, right? So ultimately your normal method calling is going to be in the synchronous form every time. Even if you run in the second time, you will see then test1 is completing from 0 to 10, and then test2 started 0 to 10, and then test3 started from 0 to 10. That's the thing. Okay, so now we can do this thing with the help of threading. So this is actually not good, right? So we don't need synchronous execution. We need asynchronous execution, and we can do with the help of threading. So to use threading, you need to insert namespace, and that namespace is using system.threading. Okay, now I can use my threads. So I have three methods, test1, test2, test3, and I want to call these methods with the help of threading concept. So just remove these things, and let me say thread t1 equals to new thread, and you will see okay, so I can call my method here, test1. Okay, and then in a very similar way, I need to create the thread2 for my method test2. I need to change the thread2, then I'll say thread3, and my method is going to be test3. Okay, now when I run this, you will see we just created threads. We haven't invoked it, we haven't started. Okay, so if I run this, you will see no output. Okay, so no output. Now you have just created the threads, but not started. So you need to start it. You can start with the help of the object of thread, like t1 dot start method, t2 dot start method, then t3 dot start method. Okay, so now if I run this, you will see a complete asynchronous output. Okay, so it can be test1 and then test2 and then test3. It can be something like test3, test2, test1, completely random, or it completely depends on your operating system or the CPU processing power. Completely depends on your CPU processing power. Okay, every time the output is going to be changed, and it differs from user's computer to the user's computer. Let me run this. See here, test1 is running from 0 to 10, and then test2 comes up. It runs from 0 to 6, you can see, and then test3 comes up, and test3 is running from 0 to 10, and then test2 started 7, 8, 9, 10. Okay, and when I run this again, you will see the another output. Another output is test1 is running from 0 to, it is running to 7, and then test2 started as execution. It's running 0, and then test3 started 0 to 3, and then again test2, and then again test1. So completely asynchronous is there. Okay, so this is good basically. because CPU is not idle here. So this is the simple threading you can understand. Now this is the asynchronous threading, right? But if you want to perform synchronous threading, how exactly I can do with the help of thread? Basically, there is a method called as lock. Keyword is there, lock keyword. So let's create a synchronous threading with thread concept. So let me just remove. Lock will not run with static keywords, so I have to remove these static keywords from my methods. So I'll just remove these. Okay, and then I will say, and then I'll say lock, and I'll pass this lock. This current method has to be locked. So okay, so now I need to do the same for test2, lock, and then this, and I'll say this. For here also, for test3 I need the lock method, and then okay, so 3 methods with lock keyword, and then I'm going to call these test1, test2, test3 in my main method. How can I call? Is with the as our method is not static, I have to create the instance of my class, and my class name is program, and I have to create the instance. So I'll say program p equals to new program, and then I'll pass this instance p dot, and p dot, and then p dot. Okay, now everything is fine. Now if I run this, you will see the synchronous execution with the help of threading. You see here, test1 is running from 0 to 10, and then test2 started from 0 to 10, and then you will see test3 started from 0 to 10. This is the first instance we are running. Let me run this again. Okay, so you can see is running from test1 is running from 0 to 10 again. Test2 started from 0 to 10 again, and then you will see the synchronous output. Test3 started from 0 to 10 again. So you can do the synchronous threading with the help of this lock keyword. Keep that in mind. If you are using lock, then your method should not be static. They are completely non-static method, and then you can call with the help of instance of a class and just call your threads. This is the simplest example of threading. I hope you understand it. Thank you so much. So we understood synchronous threading as well as asynchronous threading. Now also we had seen one of the method of thread, that is start method, right? Let's understand some other methods too, like sleep and join and abort. Let's understand sleep method first. I have test1, test2, test3 method, and if I want to make my test1 method to go for sleep for some seconds, and again I want to wake them, and again I want to wake them up, then how can I do is with the help of sleep method, right? So I have this for loop, it's working from 0 to 10, and I have this message that says test1 is running. Let me give one instruction here, so that at that particular instance of time, this test1 method is going to sleep. So I'll say if and I'll say if I equals to 5. That means when it goes from 0 to 10 at particular instance of time, that is 5, at instance of time equals to 5, this method test1 method is going to be sleep. So I'll say thread dot sleep. So thread needs a millisecond of time where it can sleep. So I'll pass 5000, that means 5 seconds. For 5 seconds this test1 method is going to sleep. And for the simplicity, I will let me pass one method too, so that it visible to you. So I'll say test1 is going to sleep. Okay, and then I will again pass a method that says test1 wakes up or woke up. Okay. So when it runs from 0 to 10 at the instance time equals to 5, this test1 method is going to be stopped, or not stopped, it's going to sleep for 5 seconds, and then again it works up. So if I run this, you will see. So you'll see test 1 is going to sleep. It will count 5 seconds, and then you will see remaining from 5 it again, it works up, and remaining task from 6 to 10 it going to be executed after the waking up. So 6, 7, 8, 9, 10. Okay, one more time if I run this, you will see test 1 is going to sleep, and it will count 5 seconds here, and then it executed test 1. See, 5, 6, 7, 8, 9, 10. Okay, so I hope you understand a sleep method, and let's understand now the join method. So thread dot join method. Now join method is basically, you see we have this main method over here, this main method, this is the entry point of the program. So the working of this main is basically here in terms of threading. The working of main is just to push these threads T1, T2, T3 so that they execute, they just start. Okay, they just start, and once they push these threads, this main is going to be terminated. Okay, so main is going to be terminated once they start these threads. So main started, main push these T1, T2, T3 to execute, and then just terminated. It will not wait that T1 gets complete his work, T2 gets complete his work, T3 gets complete his work. It's not going to wait for that, right? It just terminated. It just push these threads and just terminated themselves. Okay, that's the work. But if we want to make this explicit, like if I want to make this like I want to make this main method to wait until and unless T1 complete his work, T2 complete his work, and T3 complete his work, I can do with the help of join method. Let's understand the difference here. So let me just remove the sleep method here, and I have a simple console.write line, and okay, so I have test1, test2, test3. Now you'll see I just have a T1 start, T2 start, and T3 start. Now let me print one message here that says main is started. Okay, and then after just starting these methods, I will print another method that says main is terminated. Okay, so when I run this, what will happen? You will see this message: main 1 is started, main is terminated. These messages is going to be printed on a very on a 2-3 lines of the execution, because the work of main is just to put these test1, test2, test3 or T1, T2, T3 objects, just to push them to execute themselves, and then it terminated. Let's understand this. Okay, you see here, you see main is started. It pushes the threads T1, T2, T3 to start his work, and then it's get terminated. It will not wait that T2 is completing his work, T1 is completing his work, T3 is completing work or not. It just pushing the threads to just just starting the threads that just started, and it will not wait that they are completing his work or not. They just terminated. You see, main is started, main is terminated. Again, if I run this, you will see the same. You will see the same output. See, so it will not wait. Main is started and main is terminated, just like 1 and 2. Just wait for 1, 2, 3, and then just terminate it. It will not wait until here. It is not waiting for the complete all these threads to complete his work and then terminate. It is not working like that. So again, if I run this, you see main is, again it is in the first 3 lines, first 3 or 4 lines it is there. So main is started, main terminated. So this is without the join method. So when I use join method, what will happen? This main is going to start these T1, T2, T3, and then it will wait that these threads, they are completing their work or not. So now if I make this that T1 dot join, then T2 dot join, and then T3 dot join, this main method is going to now wait until and unless T1, T2, T3 gets complete his work. Now this main is started and main is terminated, whereas coming in the very early lines, 2-3 lines, Now this is coming in the first line, and this is going to be come in the last line until and unless this thread's going to complete their work. So you see here, main is started here, and then in the last line you see main is terminated until and unless all threads get complete this work. See output again, main is started and then main is terminated, last line. So they are waiting, the main is waiting so that all execution, all the threads get complete as work, and then the main is going to be terminated. Also one more observation is here, that test 1, test 2, test 3, they are all in the synchronous thread. You see here, test 1 is running from 0 to 10, and then test 2 is running from 0 to 10. No other method is coming in between. Test 3 is also running from 0 to 10. So again, if you run this output, same output you will see. Test 1 0 to 10, test 2 0 to 10, and test 3 is again 0 to 10. Okay, so and after that main is going to be terminated. So that's the work of join. I hope you understand it. Thank you so much.